Ever wanted to know how hot something is without getting too close for comfort? We've all been there, curious about the temperature of an object, but hesitant to risk a burn or a scald. Without risking your fingers? It's a common concern, especially when dealing with ovens, engines, or any potentially scorching surface. That's where the infrared thermometer comes in, offering a safe and convenient solution. It looks like a sci-fi ray gun, ready to zap away temperature mysteries. But it's pure science, a testament to the power of infrared technology. Point. Pull the trigger. With a simple squeeze, you're about to unlock a world of thermal information, and instantly get a temperature reading, displayed clearly on the screen. No waiting, no guessing, just instant results. This tool lets you measure heat from a safe distance, keeping you out of harm's way while providing accurate data. No burns, no mess. It's a clean, efficient, and reliable way to assess temperature in a variety of situations. Chefs, ensuring the perfect cooking temperature for culinary masterpieces, mechanics, diagnosing engine problems with precision, and engineers all rely on it for critical measurements in their respective fields. To get quick, safe readings where traditional thermometers just can't go, accessing tight spaces and hazardous environments with ease. The magic? What makes this device so incredibly useful? It's called non-contact measurement, a revolutionary approach to temperature sensing. A game-changer in science and engineering, opening up new possibilities for research and development. From satellites in space monitoring the Earth's climate and weather patterns, to doctors in clinics, quickly assessing a patient's temperature without physical contact, this principle lets us gather data safely and efficiently, streamlining processes and improving accuracy. The infrared thermometer puts this high-tech power right in your hand, making advanced temperature sensing accessible to everyone. Revealing the hidden world of heat, allowing you to see temperature differences invisible to the naked eye. Here's the secret. The fundamental principle behind how these infrared thermometers work. It's not about the air temperature or any complex calculations involving the surrounding environment. Everything around you, every single object, is constantly giving off invisible energy, infrared radiation. It's a natural phenomenon, a constant exchange of thermal energy. The hotter something is, the more intensely it glows in this infrared spectrum, even if you can't perceive it with your naked eye. Think of a stove burner glowing red, but imagine that glow extending far beyond the visible range. When you point an infrared thermometer at an object, you're essentially aiming a highly specialized sensor. A lens, much like the one in your eye or a camera, focuses that invisible infrared light, concentrating it onto a tiny, highly sensitive sensor. This sensor is the heart of the thermometer, the red laser dot you see. It's purely for aiming and targeting the area you want to measure. It doesn't play any role in the actual temperature measurement itself, it's just a guide. The thermometer collects the infrared energy that is naturally and constantly radiating from the surface of the object, not from the surrounding air. It's a crucial distinction. Think of it as a simplified one-pixel heat camera focusing all its attention on a single point. The more infrared energy the sensor detects, the higher the electrical signal it generates, and consequently the higher the temperature it displays on the screen. It's important to understand that the thermometer isn't shooting out any kind of beam or energy. It's passively receiving and interpreting the infrared radiation that's already emanating from the object you're measuring. Much like a radio receiver tuning into a specific frequency, it simply picks up the heat signal, the infrared radiation, and translates that signal into a numerical temperature reading. Understanding this fundamental principle is the key to using an infrared thermometer accurately and effectively. Ultimately, it's all about harnessing the power of the light you can't see, the invisible world of infrared radiation. So, how does invisible light become a number on the screen? Meet the Thermopile sensor. It's a stack of tiny thermocouples wired together, converting heat into a tiny electrical voltage. The hotter the object, the more voltage the Thermopile generates. The device compares this to a reference temperature inside the thermometer, using the difference to calculate the true temperature. The microprocessor inside takes this voltage, runs the math, and instantly displays the temperature in Celsius or Fahrenheit. All of this happens in a split second, from trigger pull to result. It's a perfect blend of clever engineering and modern electronics. That's how a flash of invisible light becomes a number you can trust. Ever pointed an infrared thermometer at a shiny pot and gotten a reading that just doesn't seem right? You're not alone. It's a common issue. And the reason behind it is actually quite fascinating. The culprit? It's a property called emissivity. Emissivity describes how well a surface emits infrared energy. Essentially, it's a measure of how efficiently an object radiates heat. Different materials have vastly different emissivities. Matte, dark surfaces are great emitters. They readily give off their thermal energy as infrared radiation. Because they emit heat efficiently, the thermometer reads them accurately, reflecting their true temperature. Shiny reflective surfaces like stainless steel, on the other hand, act like mirrors not just to light but also to infrared radiation. They end up reflecting heat from their surroundings, bouncing it back and confusing the sensor, making it difficult to get a true reading of the object's own temperature. The result? Inaccurate, often too low readings. You might think your shiny pot of water is cooler than it actually is. The fix stick a piece of matte black tape on the shiny surface. The tape, with its high emissivity, will provide a much more accurate surface to measure. Give the tape a minute or two to match the temperature of the object you're measuring, and then measure the tape instead. You'll get a reading that's much closer to the actual temperature of the shiny object. Industrial thermometers often let you adjust for emissivity, allowing you to compensate for different surface types and get accurate readings directly. But for most of us, a little piece of black tape does the trick just as well, providing a simple and effective solution. Understanding emissivity is the secret to unlocking the full potential of your infrared thermometer. It's the key to getting reliable results every time, no matter what you're measuring. So don't let shiny stuff fool your gun. Know your surfaces, understand how they interact with infrared radiation, and adjust your technique accordingly. That's how the pros do it, ensuring accurate and consistent temperature measurements in any situation. The infrared thermometer's versatility is incredible. It's everywhere from hospitals to steel mills. Medical versions are tuned for human skin, giving fast, precise readings for fever checks. In the kitchen, chefs use them to check everything from freezer temps to sizzling pans. Speed and control are key. Industrial models are rugged with adjustable settings for everything from rusty pipes to molten metal. They help spot overheating equipment, prevent failures, and keep workplaces safe. The core tech is the same, but each version is tailored for its job. One idea, countless applications. That's the power of a great tool. Before infrared thermometers, measuring temperature meant slow, hands-on work with glass thermometers. Infrared changed everything. Point, click, and get an instant reading. No waiting, no contact. It's a game changer for speed, safety, and efficiency, especially when you need dozens of readings fast. No more risking burns, shocks, or contamination. Just safe, clean data from a distance. You can even measure things you can't touch, like moving parts or hard-to-reach surfaces. For surface temperatures, infrared wins in almost every way. Old-school thermometers still have their place, but for most jobs, the future is non-contact. That's why infrared is the new standard. Some tools stay niche, but the infrared thermometer became essential overnight. During the COVID-19 pandemic, it was the perfect solution for fast, non-contact fever screening. Suddenly, everyone, from airports to schools, relied on it for safety. It turned a scientific principle into a frontline defense, helping us adapt and protect each other. What was once a specialist gadget became a household name. It's a testament to human ingenuity, a tool that reveals the invisible, keeps us safe, and solves real problems. From pizza ovens to public health, it's indispensable. That's the story of the infrared thermometer. A simple idea, a world of impact.